little demo of the mess of cables I've got here on the desk, otherwise known as the Super Chromat input-output node, which is this device you see here. It's a prototype. I'll be going to production soon. Hopefully have some betas out early next year of the Super Chromat input-output node. There's some stuff set up on the screen, but before I get to that, I want to talk a little bit about the motivation for this device, which works with HD, deep color, analog video. Now, I've been playing with analog video for a while, and analog video is a really interesting format. It's very clever. It manages to pack not only the pixel information, but timing and synchronization and color all into one signal. That means if you're doing stuff in analog video world, in circuitry, you need to build circuitry that'll decode those streams of information. Then you do your stuff, then you re-encode it and you spit it back out for another device to consume. So there's been a lot of people building these days modular analog video synthesizers, and each of the modules need to have this encoder and decoder built in. And depending on the level of quality and complexity and how accurate you want to be, that can easily be sort of 50% or $10, $20 of components that for a simple device might be 50% of the cost of what you're building. So you want to amortize that cost. So you end up seeing, and I haven't played with these, but I've seen all the websites and demos on YouTube and stuff. You see these modules that do a lot. You really want to amortize that cost. So you put a lot of functionality into a module, and that's cool. But if you look at the music analog synthesizer world of modular synthesizers, each of the modules themselves are much more modular. They're much more composable. They do one little thing and you buy lots of them and you plug them all together and you can make really interesting things. That's the way I've always approached building video electronics, is building little modules. And it meant that I always would make things like this. This is a precursor, I guess, of Scion, an analog one, where it does all the processing at the start and the end of the signal chain to make sure that whatever you do in the analog domain doesn't violate the timing or the color information. So this device here works with composite video. You get one signal in, it sends a signal out via a send, then it returns back in via this port, then sends out a valid composite signal there. But it means that you can do stuff in the analog domain that would otherwise corrupt your video signal. And I've been building these for a while, and you probably saw some videos if you've been following me for a while from a couple of years ago where I was making this thing better and better and better. And I was ending up spending like hundreds of dollars in components to do all of this stuff in the analog domain. And I decided to bite the bullet and build Scion, which not only does all of that, which is keeping analog signals clean for video, but it does a bunch of other cool stuff because it's in the digital domain and it has frame buffers. And in reality, it's built around this chip here in blue. I don't know if you can see my random paperclip pointer, which is an application-specific IC designed to go in the heart of professional broadcast video mixers. And so let's talk a little bit about what Scion does. So it has 3 HDMI inputs. I'm only inputting one signal right now, which is this camera here. I'm splitting that out into 2 of the sends. And if you've seen my other videos, you'll know that I can take any HDMI any HDMI 2.0 signal, so that's 4K 60, and convert it into whatever send and return format you want. So regardless of the frame rate, the color space, whether they're in sync, you get in the analog domain component signals that are completely the same resolution, the same timing, the same color, and you can set that here. Then you do your stuff in the analog domain, you send it a return in as analog. Here we have 12 bits per channel or 36 bits per pixel. I've got some typos here I need to fix. Of a very high quality ADC that can be synced locked to these, so you don't have to worry about losing sync in the analog domain, and it'll spit out HDMI, and you can configure, I think my HDMI capture can only do 8-bit 422, but I've got it configured for that right now, but you can do up to 12-bit 444 raw HDMI out as well. So that's the overview. It has a bunch of HDMI inputs. It synchronizes them all, converts them all to the same format, sends them out as analog where you can do whatever you want. And then you can come back in and get a nice, clean, locked, no dropped frames HDMI signal coming out. So what do I have here on the desk? I have this camera here going into the HDMI in over here, which I'm splitting, as you can see here, into 2 of the analog outs. that I'm then recombining with the dirty mixer circuit that you've seen here. That's just a simple potentiometer. There's nothing fancy going on in there. One of those goes straight into the dirty mixer and then back into the return, and the knob is set right now to look at that. The other channel goes out to this Mackie audio mixer. 3 channels, then go back in to the dirty mixer. So let's turn this knob and turn up these buses here. And here is Analog Josh. This is HD video being sent out through an audio mixer. This signal, this video signal, is like 150 megahertz of bandwidth. This mixer does not do that sort of bandwidth. It's lucky to do sort of maybe 100 kilohertz. It's really designed for 20 kilohertz, which is why you're getting sort of this horizontal smearing here. But it looks pretty cool, and we're not losing sync. We're not dropping frames. This is what I mean by composability. Here you can take a device that's not designed for, does not contain any sync lock circuits in there, and it can process the video. You can use your audio filters, the EQ section here, to do weird things to color. I'm just twiddling knobs somewhat randomly because I'm recording a video and it's hard to pay attention to both, but that's okay. You can use pan to move the U and V channels around. Let's blend in some of the original video so we can see what that does. And you can see my sort of shadow. Let's boost the levels a bit. This is sticking out audio level signal. So this can do like, I think audio goes up to like 12 volts usually. It's going straight back into the ADC. The ADC knows what to do. It can deal with it. It can do the black level clamping, the white levels. We're not blowing out the signal because it's smart. And all the smarts are at the end of the chain, which means you can do whatever you want in the analog domain. But wait, there's more. As I said, this chip is built around this device is built around a dedicated mixer switcher chip. And so I'm exposing all of that functionality in this client here. This client is completely open source. It talks to the Scion via Ethernet. And so you can do a bunch of stuff. So for each send, you can choose which your source is. You can do rotation. So this send is the analog send. So you can see, hopefully that's rotating around there like that. And if you feed it back into itself, you'll get spirals and twisty things and all that sort of cool stuff. You can adjust color. Now, color is super important to me. Glitch colors are cool, but having precise control over color is nice. So you've got full 12-bit LUTs here that you can go and let's go look at this channel here by itself. Whoop. You can really, these are wild colors. I'm saying color is important, but it's going through a mixer. You can control all of the LUTs here. You can unlock that. You can do your red channel. Which send are we looking at? Looking at a mix. You've got LUTs as well on the return path. You can control, change my hue around, saturation, all of those things. I said this was over Ethernet, right? I should have written a script for this. The other cool thing about it being over Ethernet is that I'm using a protocol called Open Sound Control. What's going on with my hue here? I think I did that on the return side. There we go. Open Sound Control is a protocol that a lot of DAWs use. So Ableton, Logic, all of those things. It's sort of like a modern version of MIDI that runs over Ethernet. There are tools like Touch OSC that mean you can build your own UIs. It's all open source and it can hook up. So I'm designing this for one of the big use cases is for working with live music. And so if you've got musicians who are outputting OSC from their DAW, you can sync everything that you can do in this app via OSC, which is cool. Where was I? All right, so you've got shape, you've got color. This requires some more UI improvement here. This is texture. This lets you do high pass, low pass, band pass filtering in the spatial domain. So you can do blurring, you can do edge detection. Let's build ourselves a high pass filter. Which channel will I do it on? Let's do it on the blurry channel. This one here. Let's go back over there. It's a bit too saturated for me. What am I doing here? Oh, that's what's going on there. Anyway, sorry, I can tweak knobs for hours. High pass filter would be a negative coefficient here to get some edge detection. We should probably enable it. Let's turn this one down as well. Obviously, I need to do a Z transform to map this back into normal space. Let's bump the levels up a bit so you can see that. But yeah, we are doing spatial transforms in the digital domain over this. Let's reset that back to normal. This is not a good part of the demo. Let's get this back. As I said, tweaking knobs is fun. I am peaking the levels there. Let's mix me back in here and focus. What else is there to talk about? There's a lot that this thing can do. It has, I haven't built out the screen for it now, but it can also do chroma key, luma key, upstream keying, downstream keying. I need to work out how to integrate that into a flow that makes sense in the analog domain too. So that'll be coming in future versions. It can be used as a standalone, really high quality set of DACs and a really, really high quality ADC. It's default designed to have these signals locked. So, I can completely remove the Y channel, which is where sync goes through, and our blur is not rolling around everywhere. It can have external sync on green, HV sync, so you can put RGB, VGA signals into this. It's a bunch of cool stuff it can do. I think I'm going to stop rambling. This gives you a sense of what I'm building, and I might cut now to me an hour from now after I've gone deep into playing with this stuff, just doing video feedback with an audio mixer and the Scion, because it's fun. Watch this space for more updates. We'll be launching a website soon where you can learn a little bit more and join a beta mailing list to possibly get yourself a beta device for you to test. Looking forward to your feedback. Thanks a lot. Bye.